9-2, rational exponents. So we're going to focus mostly on the rational definition, and for this first part, we've already worked with them last section, so it's interesting how they break this into a separate section. What is a rational number? A rational number, typically, we write fraction, a ratio, it could be. You're comparing two numbers. I mean, that's more specifically for a ratio, but a fraction, so an example, 3 is a rational number because you make 3 over 1. 0.25 is a rational number. Irrational would be continuing forever without any pattern. So E, if you know what E is, E, we're going to learn about later, is an irrational number. It continues forever without a pattern. Pi would be an irrational number as well. Oh, did I miss a page from last time? I did not miss a page from last time, so I don't know where that page went, but this acronym that we talked about last chapter, maybe I did. I can't remember if I did or not. I think I did. Is this. So, rational numbers can be any of these. So, F stands for fraction. So, that's your most obvious one. A is just and. Fractions and repeating and terminating decimals. So a fraction I can write as 1/9. A repeating decimal would be 0.1111111. That's 1/9 as a decimal. If I wrote 1/4 as a fraction, then it'd be 0.25. It ends, it terminates. That's also a rational number. So give an example of a rational exponent, x to the 3/2. That's a fraction. It's also an exponent. Thus, it's a rational exponent. And the rational exponent theorem, I'm going to just use the letters. So this is x to the mnth power is the same thing as saying I can take the root of it first, then the power, or I can take the power and then take the root. So we've already done a practice one of this when I was talking about flower power, how the exponent's your power and your numerator's the power, and the denominator is your root. The whole thing is your exponent. So how is it helpful? Think about it. So if I asked you to do 256 to the 3/2, does that look fun? Nope. But if I take the square root and make it a smaller number and then cube it, that's a little better because I can break it down. Now, sometimes it might be that, let's see, well, that's a funny number. 5 to the, and then square root. Okay. Can I take 5 to the square root really fast? No, but I can take 5 cubed. That's nice. That's 125. Then I can take the square root of it. I only have to then use my calculator one time instead of having to use it 2 times. So it makes life a little simpler. Example 1, we're doing the same thing, but 3 different ways. So they want us to find 64 to the 2/3 power. So we already know 2 of them. We already know 2 ways. So 64, I can take the cube root first, then square it. We've done the cube root of this before, so I know it's just 4. And 4 squared will be 16. Okay, so that's one way. Second way, can you reverse it? Can you take the square root first, or the cube root, or square it first, then take the cube root? So I'm going to square it first, then do the cube root. So 64 squared, that's 64 squared, is 4,096. Now if I take the cube root of the answer, I will get 16. All right. And then the third way, is it just to write it in your calculator? Oh, okay. That's a cool way. What else do we know that makes 64? This is actually, okay, there's more than 3 ways, and you don't have to do this last way at all. But, okay, so I know that 8 squared makes 64. So I'm just replacing the 64 with 8 squared. Okay, so that's the same thing as saying 8 to the 4/3 exponent. Ooh, do I know the cube root of 8? Can I do 8 to the 1/3 and then to the 4th root? The cube root of 8 is just 2, and then 2 to the 4th is 16. So it took more steps, but I didn't have to figure out the 4096 thing. And if I was really bad at cube roots, this only used square roots. Well, I guess it used cube roots, but it used a basic one. So I would also make sure that you know what's 1 cubed, or what's 0 cubed, what's 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed. 6 cubed is nice. You'll typically not see anything above 6, maybe 7. I like 7 just because it's a fun number. It's 343. 6 is 216, 125, 64, 27, 8, 1, and 0. I've maybe once done something with 8 cubed. But if it's higher than this, you're going to use your calculator anyway. So I would say at least the first 5, maybe the first 6, you'll really need to know. So, all right, next page.